Good afternoon, dear participant. Today we will discuss geospatial application in crop resource monitoring and assessment. So this is a one part of topic addressing nature resource management, application of remote sensing and GIS. As all of we know, agriculture is one of the most important sector that contributes not only to livelihood of people but also to cultural diversity. So here I have done my this lecture with different outline. First we will cover crop inventory, some application for how we can estimate crop yield, we can estimate crop condition and drought, some example of irrigation management, horticulture development, some example particularly related to industry like crop insurance, hyperspectral remote sensing, and latest how we can use UAV or drone in agriculture. Let us understand how agriculture is important. It provides not only food security but also sustain livelihood for the people. As we all know, more than 70% of people in rural area depends on agriculture for their livelihood, and about 45% of area, total geographical area covered under agriculture. Apart from this, if you see, agriculture sector is changing socio-economic environment of population with liberalization policy, globalization, and recently under Prime Minister Narendra Modi government, it is now agriculture is transforming digitally. So that is digital transformation. Agriculture sector is central to the different kind of goal, which is called sustainable development goal. Zero hunger, life on land, climate action, all these different kind of goals directly linked to the food security, energy security, and environmental security. So overall, agriculture continue to enjoy or play an important role in achieving enhancing Indian economy by not only contributing to have enough food, but also it provides ample scope for the an opportunity for the employment. More than 50% people depends on agriculture for their livelihood. India is a big country, 329 million hectare land, and we have around 151 million hectare land under agriculture cultivation. So if we see, there are different kind of crops practiced across the length and breadth of our country. One of them is food grain crops. So we are self-sufficient in food grain production. Right now, we are the current year we are having almost more than 315 tons of food grain production we have achieved. Horticulture also we are progressing well. We have more than 340 million tons of horticulture. Net irrigator area or expansion of irrigation is also happening in India through construction of different dams and irrigation project. Agriculture as such contribute nowadays 18%. But 20 years back it was more than 35% contribution from agriculture sector. But recent days major emphasis is given to the service and industrial sector. But anyway, agriculture still remain in focus because it generate vast employment opportunity. Problem with Indian agriculture when we talk with respect to the remote sensing is a field size. India is a very big country but more or less fragmented land holding. So average field size is very smaller. Even though small size, which is a limitation to adopt remote sensing application, more than 65% of all remote sensing application realize by India is mainly for agriculture sector. So what I mean to say, more than 65% of remote sensing data are being used for only agriculture sector. So it enjoy special privilege. Whenever there is calamity is there or anything for agriculture monitoring, all satellites are looking at the agriculture. So it is the utmost priority of not only for the government but also to help farmer for better society. India, there is a large scale diversity in agriculture because of varying kind of climate regime, soil types, topography, and kind of cultivation practice. So we have got in India rainfall around 250 mm rainfall in desert to almost more than 2000 mm rainfall in Himalayan terrain like Uttarakhand where we are placed and Himachal Pradesh. So climate regime ranging from arid to almost per humid. Similarly, soil types, alluvial soil we will find in Indo-Gangetic plain, gravel in the mountain, some lateritic soil in the peninsula, black soil also in some Maharashtra region. So we have got different kind of soil types also which provide different kind of fertility aspect to agriculture. Similarly, physiography, we have rock mountains, we have desert, we have rock outcrop, we have coastal region, we have this alluvial plain, that is Indo-Gangetic plain. So their physiography and geomorphology is quite significantly different. So because of this large scale variability in the soil, climate and physiography, we have got large number of crop practice across the length and breadth depending upon the kind of soil, climate and terrain resources available. So here you can see we have in mountain ecosystem mainly will find maize or maize based system, or some in Indo-Gangetic plain rice wheat system. In Gujarat that is a groundnut based system, and rice in mainly in the eastern part of India, eastern state we will get rice. So there is a different kind of cropping practice which are being cropping pattern which are being practiced across India. Let us understand first how remote sensing works. What is remote sensing? Mainly it is acquiring information about surface feature or target without having physical contact with it. Means we are sensing information like our eyes from the distance and interpreting it for better assessment. So we are acquiring information with the sensor in the space orbit and providing this data to at the ground station to make certain kind of interpretation. So there are two type of remote sensing. One is passive remote sensing, another is a active remote sensing. Passive remote sensing means that it works with the optical domain. Whenever there is a amount of energy which is either reflected from the surface or emitted from the surface, which is detected by the sensor, means any energy which goes from here from surface, whether vegetation or rock or soil, which is detected by the sensor and it is recorded and sent to the ground station, and ground station we can translate into a image, and image is interpreted by the scientific community for assessment of different crop types, different soil types or different forest types and so on. So that way amount of energy, that is passive energy, because it is not sun energy which is received natural source, natural light which is reflected from the earth surface or emitted from the earth surface is detected by the sensor and recorded at the ground station. But in case of active remote sensing, sensor itself has got its own illuminating source. It sends the beam of signal to the vegetation and backscatter radiation is being recorded by the sensor and it is further sent to the ground station and data is processed and converted into a satellite image. So this is a two-way of remote sensing. That is a active remote sensing. It is independent of weather, so it can provide you a cloud-free data or good quality data even during the cloudy season. So that is the main limitation of this optical remote sensing. That is why when our rice is a first and foremost staple crop. And if we want to monitor rice, we need a data during cloudy season, rainy season. So for monitoring rice crop, we need a active micro remote sensing technique, that is mainly a synthetic aperture radar. We'll see all those kind of technique later. Earth observation, they are comprising of different kind of images, airborne images, satellite images, or you can say UAV images. Every image has got certain kind of parameter like spatial resolution, temporal resolution, or spectral resolution. Temporal resolution means frequent repeat cycle. How frequently you are acquiring image from of a particular target or particular field. That is called temporal resolution. Partial resolution means minimum distance what we can map with particular sensor on the ground. So suppose field size is very small, even though we want to map that field size, then we require very high partial resolution in the order of less than 5 meter. Spectral resolution means number of spectral band. How many spectral domain or spectral bands a sensor is recording observation from the surface. Similarly, GIS, it is a one kind of database management which offer versatile tool to input, store, analyze, and visualize the partial and non-partial data. Partial data means any image, some maps, or any drone image. Those can be integrated with non-partial data like crop cutting experiment, soil moisture observation, or biophysical measurement. All those are point-based measurement what we are measuring with the one or another kind of instrument. So both data can be integrated and certain kind of modeling can be done to prepare certain kind of maps, whether it is a yield map, crop map, or you can say irrigation map. So there are various kind of technology which part of the geomatics, including RA, GIS, GPS. GPS nothing but global positioning system, which is called nowadays global navigation system of system. It provides locational accuracy about particular instrument, like particularly in agriculture. When we do precision agriculture, there it provides location accuracy of the variable rate technology equipment, while it can be useful for the varying different rate of seeds, varying different kind of input application within while moving in the field. So there is a VRT kind of equipment are there. They can be monitored with the locational accuracy or information available from the GPS, high resolution GPS. So always we shall think of synergy of this technology, GPS, satellite remote sensing, and GIS. So we can have some informed decision making. So because this all knowledge is very much useful for making certain informed decision related to farming operation, or you can say like production forecasting, or it helps also in the irrigation decision support. So let us understand in agriculture sector, mainly particular crop, what kind of information are required and at what different times. So in beginning from the growing season, before crop is planted or it is sown, we require first information about weather forecast. Now in the month of mid of June, every farmer is looking at the sky, whether when there will be a rain, so he can prepare his field for sowing certain crop. He is eagerly waiting. So if we can forecast with good accuracy weather forecast, then it can help farmer. So how we can improve the weather forecast? By assimilation of satellite based radiance or satellite data, whether it is INSAT 3DR or scatterometer or PICSAT or the certain kind of earth resource satellite, which are also providing good information to improve weather forecast. So weather forecast can be improved with use of satellite based data, whether it is a water vapor, rainfall, all can be inputted in the weather model, numerical weather model, to improve weather forecast. Second, farmer require initial soil moisture. What is the soil moisture condition in the field, then only farmer will grow. Farmer will, okay, even we forecasted, farmer will not believe. Farmer will go to the field and he will check whether how much soil moisture is there. So if we provide that information on initial soil moisture, what is the percentage of soil moisture is there in the topsoil, then farmer will immediately, okay, use those information of his field for whether his field is ready for land preparation or sowing crop. So that is very much vital. And soil moisture information, mainly topsoil, certain, okay, or other depth wise also we can do with the either active remote sensing data like radar or optical and thermal integration as well as spectrometer. So there are different kind of technique that helps you to get soil moisture either from passive microwave or active microwave. Then actual rainfall. Once, okay, crop started growing, then we require information is required about actual rainfall, because if there is a very good forecast or rainfall is there, then farmer can use this information for the whether he has to irrigate or not. So if there is a actual rainfall is there, then farmer can avoid irrigating his field and he make use advantage of that one irrigation. Then during the vegetative growth stage, farmer also require information about weather, crop condition and pest and disease. So what kind of pest and disease are right now, okay, affecting his crop. Also what kind of weather is there. If weather is dry, then farmer will take decision about irrigation. So if weather is very dry, then crop may require more water. Farmer has to irrigate more frequently. If crop condition is poor, then farmer can also do certain kind of farm management operation like applying fertilizer, applying irrigation, so he can maintain crop condition. Then pest and disease, if there is a pest and disease, he can information or which can be detected with the remote sensing, pest and disease. With multi-source data, hyperspectral remote sensing, all can be useful for pest disease detection. If pest score is estimated, then it provided to the farmer. The farmer logically, you provide into logical interpretation of this pest information, then farmer can use that information for making certain kind of pest management tactics, applying certain pest management techniques. Then after, even at the maturity, after maturity also remote sensing technique or geospatial technique is very vital, because if once harvested crop during the last week of October, then farmer has to market this produce. So marketing as well as cold storage facility, deciding optimal location of cold storage, optimal location of food processing park, all require very good information where farmer can find easily accessible cold storage or easily accessible food processing park. So that information can also be generated with the integration of geospatial information. Either we can get from the satellite as well as in situ observation. Even after that, even harvesting, then there are certain crop like in November, if we can provide information what is the residual soil moisture in the field. So that residual soil moisture information is very vital for the farmers, because if you provide that there is enough residual moisture which can sustain for almost 1.5 months, then farmer can be advised to take another short duration crop like pea or chickpea. So farmer can sow another chickpea or pea kind of crop, so he can have better income. So throughout growing season, from beginning of the crop to the even harvesting and even after harvesting, also remote sensing and geospatial technology helps farmer or farming community too. So there are various kind of potential or remote sensing data being practiced and operationally being utilized for the agriculture sector, beginning with the agriculture land monitoring, crop acreage estimation, agriculture drought assessment, horticulture development, cropping system analysis, command area, irrigation command area monitoring and performance evaluation, soil mapping, pest and disease monitoring, detection and forecast forewarning, aquaculture mapping, inland aquaculture mapping. So various vast amount of application being realized with the use of satellite data in agriculture sector. So agriculture is backbone of Indian economy, and India is one of the few country which has adopted this satellite remote sensing technology or space technology in generating regular database on crop production statistics and providing very good input to achieve sustainable agriculture. So satellite data either in optical domain or radar, they are being used widely and more frequently in agriculture sector for monitoring agriculture. So what kind of feature of remote sensing data? Well, they are providing multispectral observation. The satellite data also allows crop discrimination, means what are the different kind of crops cultivated, discrimination, and crop growth assessment, means different sensors are there. Satellite sensor has got different number of spectral band, maybe like okay list 3, I'll show you list 3 is having 4 number of spectral bands. So it allows more number of crop discriminated and also crop growth assessment. Similarly, also synoptic coverage, how much area it is a particular sensor covered in a particular pass, one pass. So with more large synoptic coverage, then it can enable to monitor whole state with the dynamically by particular sensor like advanced sweeps or coarse resolution data which has got higher synoptic coverage, so they can enable farmer to monitor crop over a large area. Then spatial resolution. Spatial resolution also, that means ability of a sensor to detect or resolve minimal mappable area on the ground, that is called partial resolution. So this partial resolution very much vital when we are talking about the discriminating crops in the very mixed region. If very mixed region or heterogeneous region is there, we require very large spatial resolution data. If it is a homogeneous region like okay Indo-Gangetic Plain, Haryana, Punjab, we require coarse resolution data. Even I mean to say coarse resolution data also can suffice. Then multitemporal. Multitemporal means frequent revisit capability of a satellite sensor. So a particular sensor how frequently visiting the same area and acquiring observation. That is the main point behind frequent revisit cycle. Then also multiple utility. Multiple utility means same data. Like once we have acquired a list 3 image, so same image can be used also for crop discrimination. Same image can be used also forest type classification. It can also be used for the urban feature mapping. It can also be used for water resource and many other aspects. So same data can be used for different kind of thematic application. Last, that archival. The satellite data which can be stored and archived as and when required. So nowadays there are okay satellite like okay NOAA, MODIS, which are running for more than 20 years. All that 20 years of data on a daily basis they are available. So once we are having historical archive of the large amount of data over whole globe, that means like NOAA, GIS NDVI is a one example which is available right now for the more than 40 years of data. Those 40 years of data once available, then it can provide you a very good earth observation signal of climate change. So those archival is very much useful and historical data for developing climate change signal. Here you see there are different kind of satellites are available with different partial resolution, temporal resolution and features. So we are having Indian remote sensing satellite data list 4, list 3. We are having satellite is a resource set 1 and resource set 2. So resource set 1 and 2 which is carrying 3 payload, list 4, list 3 and advanced sweeps. These are workhorse satellite which are very vital for monitoring agriculture sector. And during cloudy season we are having a reset radar imaging satellite which provides you a all continuous and weather independent observation. So it can provide in different polarization angle with the seabed. So that is very much useful for especially for rice crop monitoring during Kharif season. Then we also have OCM, ocean color monitor. It is mainly designed for, it was designed mainly for the ocean color, but it has got practical utility for generating crop condition also, or monitoring drought based on vegetation index also. So now let us understand what is crop type discrimination, because as we know, every crop has got different kind of physiological, morphological characteristics. Leaf, shape, size, color, crop geometry, all are different for the different crops. Similarly, a remote sensing sensor which can detect amount of energy which is reflected from the particular crop in the different domain. So different object means here different crops has got different kind of reflectance, or reflect different amount of energy in the different wavelength domain of the electromagnetic spectrum. Here this is, you can say, 300 to this 1100. This is a visible and NIR electromagnetic spectrum. So here you can see different is there, visible domain there, okay, more absorption is there, and thus NIR domain more reflectance is there for the vegetation, but for soil it is different. So different amount of energy being reflected in the different wavelength domain of the electromagnetic spectrum by either soil or different kind of crops. So this different absorption and reflectance pattern form a unique signature which is called spectral signature. So based on this kind of spectral signature, you see here green visible light, then near infrared and sphere. Here in red, that means chlorophyll absorption. In plant mainly there is a chlorophyll pigment, and those chlorophyll pigment plays a role in absorbing visible light, and red is the most prominent portion of this visible light. So visible light mainly absorb, but near infrared which is mainly scattered because of very good healthy cell wall, because NIR always gets scattered at the more cell wall interface. So multiple scattering we will find wherever there is a interstitial space is more. When interstitial space is more, when crop is healthy or crop is in good condition. So NIR mainly healthy crop scatter more. Now here you see there are three crops: wheat, sugarcane and mustard. Wheat, that is first, and mustard and sugarcane. Based on their different reflectance in the near infrared and red, it is possible to discriminate. Why this very high reflectance, particularly here in case of near infrared region, this is the spectra required during the March, because in March, mid of, so sorry, not March, first week of March. So first week of March, wheat crop is in the maximum vegetative growth stage. Mustard almost matured, only lower leaves are green. So here maximum vegetative growth stage, so very highest reflectance in NIR. Here in case of mustard, top leaves are dried but lower leaves are still green, so there it falls in second category. But in case of sugarcane, almost by February crop is harvested. Farmer are leaving only some small stem to regrow next year, so that stem or traces cannot reflect. That is why it is the last. So depending upon the how good a the cellular structure or well cellular structure is there or not, or chlorophyll absorption is there or not, it gives different kind of signature. So as I said, different kind of crop characteristics affect the canopy reflectance. First, crop type identification is more concerned with classifying all crop types from each other. When we are classifying one crop from another, then it is called crop type identification, because our interest or our objective is to distinguish each and every crop that is being practiced in a region. That is objective, then it is called crop type identification or crop type discrimination. But crop acreage estimation means different. It concerns mainly with the only target crops. Suppose take example, we are interested to have acreage estimation of Haryana. Wheat crop acreage estimation of Haryana. So our main focus is on wheat. So our all methodology, kind of satellite data selection, date of acquisition of satellite, timing means time, date of satellite data acquisition, all should be suited with the means particularly very suitable with the wheat crop. So wheat crop, it reached to the peak anthesis stage, maximum vegetative growth stage in the end of February. So we shall acquire satellite data like list 3 particularly during the last week of February. Then we can get the better accuracy. So here, but we are in Haryana, there is other crops are also mustard, other crops are also practice. But our more interest is acreage estimation of wheat. So our knowledge, our data acquisition, kind of satellite data, our ground truth campaign, everything shall be directed mainly focus with the major focus on wheat crop. There are different kind of approach that can be useful for agriculture crop type mapping. One is a boundary overlaying approach. Boundary overlaying approach means only complete enumeration technique. That is when we are working with the small administrative unit like tehsil or district. So that can be reachable with the ground truth data collection. So when administrative unit either district or taluka, then we can apply this boundary overlaying approach with the more number of ground truth. Here only acquisition of satellite data. Then the administrative unit boundary like here tehsil boundary is used to mask satellite image. Once we got this satellite image, this is a FCC, false color composite, which means different NIR, red and green applied to the red RGB, then it is a FCC. And that this FCC, false color composite image, with the computer algorithm we are classifying with the certain ground truth. So first we identify which are the different kind of crop type practice across the area, that is which is called training signature. So we select first training signature. After generating training signature or identifying those training site, means different kind of crops where it is practiced and labeling different kind of crops, then we can ask computer algorithm like maximum likelihood classifier, or nowadays okay even artificial neural network, that is also one classification algorithm. We can ask this kind of algorithm to classify based on the ground truth data or based on the training data all pixel across the region. Then it classify based on the maximum likelihood probability of a particular class to be a member of that particular information class. That is a maximum likelihood probability classification, which is called MXL classification. So here you can see sugarcane, paddy, sunflower, groundnut. These are all classified particularly for the Kolhapur Tehsil in the Maharashtra. Similarly, here also there is a Saharanpur, our nearby occur here in to Dehradun nearby district Saharanpur. There also we in during the Kharif season end we acquire list 3 image and we could able to succeed to classify basmati rice and non-basmati rice also. Here you can see both basmati and non-basmati has got different signature. But this doesn't mean that you can classify variety with the list 3 kind of data. Not possible with the multispectral remote sensing like list 3 or Landsat. There you require hyperspectral kind of data. But when, because this is a unique case where okay, because of different type of sowing and a different type of time of harvesting of Sarbati and Basmati variety, we could able to classify with the single date. But it is not always recommended that we can use multispectral data to classify different kind of variety. For varietal discrimination, it is always advisable to make use of hyperspectral data. This is another example, Haryana. Now things also comes to your mind that how we can classify whole state like Haryana, because here we have used advanced shifts data, but Haryana is a kind of state where okay during the Kharif Rabi season you will find homogeneous synthetic field size is more than 1 kilometer. So homogeneous, continuous and homogeneous patches of wheat crop is there. So they are specifically confined to the particular kind of district cultivation of wheat crop, mustard and sugarcane. So we can find bigger patches of crops in this area. So single date course resolution data can also suffice your classification without compromising much on the accuracy point of view. So here you can say we have used advanced Swift data and we can classify. You see advanced Swift data, it is okay giving certain error compared to the least 3 data, but even though you can get 70 to 60 to 70% accuracy of getting crop coverage, wheat crop area estimation with advanced Swift. Single date. This is called single date. If you are having advanced Swift data 4 or 5 date, definitely you can get accuracy above 80%. Another, suppose, because that is all about, okay, you can say one district or one tehsil, but India is very big country, state, different states are there. Now if you government want to have wheat acreage estimation continuously in an operational manner, so we are having already operational project, and there is a one center, Mahalanobis National Crop Forecast Center, which is operationally monitoring agriculture, providing acreage estimation of different district level of major dominant crops, more than 15 crops across India. Now, for those kind of all crops, major crops, forecasting whole India, major dominant growing district, different forecast, 4 forecast is given, before season, mid and end, different forecast is given. So for that kind of methodology, you cannot use simply boundary layer or boundary overlaying approach. You have to do certain stratified sampling approach, because stratified sampling approach means whole country or state you can divide into different kind of strata based on the agroclimatic zone, maybe based on the previous year crop area estimation or previous year imagery. Then only those whole state or country divided into a different sample segment of the order of 5 by 5 kilometer, 7.5 by 7.5 kilometer, what both sides. If you are having more heterogeneity, you can use lesser size like 5 by 5 kilometer. If you like Haryana, where okay heterogeneity is less, you can use 7.5 by 7.5 kilometer segment size. That means this square box. So this individual square box is only 10% of this square box, where sample segment is being used for the acquisition of satellite image and classified. So you are seeing this all square box, that is only 5 by 5 kilometer or 7.57 kilometer. Those are only classified. So in a particular district only you will find 4 or 5. In one district you will find 4 or 5 only segment. You classify and extrapolate based on the stratum proportion of the crop area of that particular district. So finally we aggregate this segment based crop acreage estimation along with the stratum proportion and finally get the district level estimation. But there is also nationwide forecasting. It doesn't only depends on classification or ground truth, all those things. People have developed also a multi-date data, like okay WIPS data or advanced WIPS data. Now people are using also advanced WIPS to make spectral profile of the crop, and based on the crop sowing, when it reaches to the peak and harvesting. So by studying entire spectral growth profile of a mustard and wheat, you can easily able to discriminate two crops. Here you see this is the red line that depicts the spectral growth profile, means NDVI profile of the wheat crop, and this is blue line that indicates the spectral growth profile or NDVI profile of the mustard crop. Now things comes to in your mind, why these are too deep here? Because once okay crop is sown in the last week of October, then in the month of December, month of first mid of December, it reached to the peak growth stage, means leaf all peak growth stage. So it reached to the NDVI reached to the peak. Then after it turns yellow because of flowering. Mustard, because of flowering, it turns yellow. And flower doesn't have chlorophyll concentration. When chlorophyll absorption reduces, as a result, NDVI goes down. Then again, that flowers turns into a pods. The pods adds to the new green area index, means more chlorophyll concentration. So again, because of this leaf area along with the green pod area, both adding to the more chlorophyll absorption, as a result, again it receive another peak. Then after, there is a senescence of the crop, means maturity, drying of leaves, falling of leaves. So again it goes down. So this is peculiar to deep to peak is obtained in case of mustard crop, but other crops, it is wheat crop, it is only single peak. So this kind of information is very much vital. So when you want to classify mustard is a main target crop, you should always acquire your satellite data, mainly these three kind of image during the flowering stage. So you can acquire during the first or second week of January in case of Western UP or Haryana. So this is also, you can see, okay, high resolution crop forecast if you want to give like sugarcane. So here there was one project, okay, we have taken for decision tree classifier or image segmentation. That is the advanced classification techniques. The image segmentation, first image is converted into a segment, then those segments are classified. Image segmentation is done based on this not only spectral composition, spectral data, it also use the other ancillary information like shape, size, and other things. So here mainly list 3 and list 4 data, they are used mainly to classify ratoon and sugarcane crop, planted sugarcane. Ratoon means first plant, farmer plant crop during the May, and then it is getting harvested in the month of October, then getting harvested in the month of February, and that leaving the 1.5 feet stem to regrow next year. So those which plant stem which regrow next year is called ratoon. First year is a planted cane. So here you can see list 3 single date, list 4 single date gives with the error is only 7.8%. But when you are having even coarse resolution like list 3, but multi-date, here you see multi-date, ratoon and both clearly different. So multi-date data, 3 dates data, it is improving the classification accuracy. So India, if you are doing only rice and wheat, you can use okay coarse resolution kind of data. But when you are interested in the state level, you can use advanced WIPS 60-meter resolution. If you are interested at district level information, but 2 or 3 more crops, you can use list 3 kind of resolution. If you are interested in block level, like mandal level, more than 3 or 4 crops, you can use 6-meter list 4 kind of resolution. If better, even beyond that, nowadays, okay, Iconos, QuickBird, PlanetScope, many data are available which are having a in the partial resolution in the order of 1 meter, 1 to 3 meter. So those can be used for the village level mapping or field scale mapping, cadastral level mapping. So India has got wide range of satellite data which are available from 360 meter OCN to almost list 4 data. Nowadays, many private global satellites are available providing information at very high partial resolution like PlanetScope, QuickBird, Rapid Eye. Those are very high resolution satellite with the constellation available to monitor crop in a timely manner with the high accuracy. There is another kind of remote sensing, that is backscatter, temporal backscatter. Active microwave remote sensing. Active microwave remote sensing means it uses its own illuminating source of for and receiving backscatter from the crop. Active remote sensing sensor are reset, radar set, the like okay ERS, and also we are having okay Sentinel-1. Those are mainly a microwave satellite, active microwave satellite. Now here you see how we can use it for the paddy crop monitoring. First, because radar scatter when rice crop is not planted, before planting we put water in the field. When before planting water is in the field, then at that time you will find specular backscatter. So specular backscatter. Then after, once crop is planted, specular backscatter. Then after, okay, once crop is emerged, volume scattering is there. So this particular difference is deep because of specular backscatter. This deep is there. That deep gives you a vital information or indication about the rice crop. So urban rice and this water you can easily monitor. So then after, volume scattering is there because of vegetation growth. That is why it has become very versatile to make use of synthetic aperture radar like SAR data for rice crop monitoring. Here you can see one example where early stage and late stage, early means yellow and late stage magenta color, with the different kind of horizontal polarization and the HS polarization in the different 3 dates of reset is used to monitor rice crop. Rice crop growth stage, basmati, non-basmati. Again, okay, earlier I have given example of basmati, non-basmati with the multispectral. But same data like, okay, active micro remote sensing like radar set, that can also provide you a vital information if you are having a multi-day data. Here you can see 1, 2, 3, 4, 5, 6, 7. 7 dates of radar set is acquired. So here you can see different. That one particularly basmati and non-basmati. Basmati is brown and this non-basmati is blue. So you can see at the later on stage, non-basmati is harvesting earlier compared to the basmati. So because of this difference in the harvesting or growth stage beyond peak vegetative growth stage, we can easily able to classify this basmati and non-basmati because of difference in the seasonality or difference in the phenological cycle of the two variety. So if we have multi-day data, it is quite easy to classify different kind of variety which are having a different kind of characteristic and growth cycle. Crop yield estimation. Why we need to forecast crop yield? Crop yield is nothing but production per unit area. That is called crop yield. Crop yield is manifestation of weather, soil management, and poses very good challenge to the because crop yield is nothing but it is a final outcome of good soil, good management, and good climate. And similarly, spectral data, what we are talking about, remote sensing data, they are also a spectral manifestation of crop, soil, and management. That is why spectral data are better correlated with the crop yield. They are spectral manifestation of climate, soil, and water management, climate, soil, and agronomic management conditions. Similarly, a crop yield. That is why there is a direct correlation exists between spectral data as well as crop yield. Crop yield estimation mainly key to food security, and it is useful mainly for many decisions like import export. Whenever there is a shortfall, like drought is there or flood is there, whole crop is damaged, then we need to provide food to each and every individual of our nation. In that case, government has take certain decision of importing those kind of food grain which are damaged or not having enough food available in our food grain available in our godowns. Then government has to take decision based on the shortfall of the food grain production. This decision to import those kind of food grain crops or it produce. And whenever there is surplus, when surplus production is there, forecast is there, then government take decision to export those kind of agriculture commodity to other countries and earn revenue. That is called import export decision. Another, minimum support price. Like this government has introduced minimum support price for all 24 crops. Today, earlier it was only 12 crops. Now all even ragi, cumin, all you can bajra, many crops, they are covered under the minimum support price. And minimum support price, whenever there is shortfall or farmer crisis are there, or when there's surplus production, these fluctuate based on the shortfall or based on the availability of food, agriculture commodity and its production in the nation. So government decide to support farmer or for the welfare of farmer, a minimum support price is decided to avoid any kind of farming crisis. Then so how we can develop yield estimation system, because satellite has got certain unique ability to supply observation over large area, synoptic viewing ability, multispectral observation, multiple utility, and also high partial user specific partial resolution. We have discussed this remote sensing data characteristics earlier. So this all helps to develop very good yield estimation system. And there is a strong relationship between satellite derived parameter like vegetation index and crop parameter like leaf area index, biomass, or other. GIS, which provide very good tool or database management system to integrate those crop observation, soil observation, climatic information along with the satellite derived information to run certain kind of model like crop simulation model, which require management, weather, weather management and soil. So those you can integrate those information to drive sophisticated crop simulation model along with the remote sensing. So there are different kind of approach: spectral yield model, spectral profile, deterministic biomass model, and so on. So let us take an example. This is one simple statistical yield model. If you want to estimate for small region, you can take one satellite image during the vegetative growth, maximum vegetative growth stage of wheat crop. Classify them to different crops. Here our interest is wheat crop. So we have classified into a wheat. Then wheat crop, those NDVI image which is calculated from the list 3 image is mass with the wheat crop mass. Then wheat crop NDVI is correlated with the crop cutting experiment what planned during the ground truth observation like this. Taking groundnut GPS location, latitude, longitude, as well as 1 by 1 square triangle that is thrown to the field, and wherever it falls, that much portion is harvested as a crop cutting experiment, and those crop cutting experiment based yield is related with the NDVI of those location. Now here see, these are the all crop cutting experiment location, and NDVI image for the NDVI values for these location extracted and related with the crop yield. Then classification, and this is a particular NDVI image. You see yield map. So majority of this Saharanpur tehsil, which is falling with between 35 to 45 quintal per hectare wheat crop, and mainly which is the best model, NDVI, land productivity index, and irrigation frequency. Here we have tested in management, that means irrigation frequency, remote sensing, that means NDVI, and soil information, mainly land productivity index based on depth, soil texture, drainage condition, all. So all three that giving best yield estimation for the wheat crop in Saharanpur. Similarly, crop phenology, another crop phenology means timing of occurrence of different crop growth stage within the growing cycle of crop. So here this is cotton crop. In cotton crop we could able to estimate when crop is start of season, means start of greening, peak growth stage, end of greening means end of season, length of growing season, and this amplitude, maximum peak value of NDVI, minimum value of NDVI, and difference between peak and minimum, that is amplitude. All those phenological matrices we can compute and relate with the yield. So finally we can estimate, after relation we could find peak value, amplitude, and length of growing season is good independent variable explaining majority of variation in the cotton yield in case of Maharashtra. So this is a Marathwada region where okay, this is peak value, amplitude image, and length of growing season image. All three are put into the equation. Finally, you can get yield map, lint yield. This is a cotton lint yield of the Marathwada region. Another model, that is a deterministic semi-physical growth model, which is mainly based on the light use efficiency. Here, all of we know, those who are agriculture especially, how plant make food. Plant make food through photosynthesis, process called photosynthesis. So plant uses light in presence of water. An enzyme called ribosco convert carbon dioxide and water into a carbohydrate and oxygen. That is a simple equation. So that photosynthesis process, we can estimate this gross photosynthesis, net photosynthesis or net primary productivity, and multiply it with the harvest index. Harvest index means ratio of economic yield to the biological yield. So in case of wheat crop, harvest index is 0.35 on an average. For rice crop, it is around 0.4. So once we can, how we get different parameter? FFR, fraction of absorbed photosynthetic active radiation, we can get from the satellite. PAR, photosynthetic active radiation, this is nothing but visible light. So magnitude of visible light, that we can model from the satellite. Nowadays, okay, there are satellite like INSAT 3D. We can get image also. Solar radiation estimate now available from the MOSDAC. We have got Space Application Center, which is hosting a portal called MOSDAC, from where you will get solar radiation estimates also. And 45% of this solar radiation is called PAR. FFR you can get from Modi's, or you can get also from other satellite if you are having certain measurement. Light use efficiency, that is also nowadays possible with the different kind of satellite. But even though you can do use certain stress scalar and compute light use efficiency, finally you can work out yield. Here you see for Haryana wheat area classified NDVI particular 8 day, 8 day according to Modi's temporal resolution, NDVI from Modi's. Then PAR. This PAR is not from satellite, but we have estimated from meteorological observation based on sunshine recorder. Then FFR, that means PAR, FFR multiplied by this, okay, PAR equal to APAR, light use efficiency, and finally we can get every 8 day net primary productivity. When you sum over the whole growing season and multiply with harvest index, you will get yield. You see, this is the Haryana yield. Majority of district you are getting yield estimate within the 10% official estimate, even in Western UP also. So you can say that this semi-physical model works very well, and it is a very scientific and straightforward physics. But problem with is we cannot make, okay, very good advanced forecasting. But yield estimation is very accurate, and it is also giving you a partially varying yield. Not district level, regional estimate, you can get even partially varying yield. You see different. Now our Mahalanobis National Crop Forecasting Center, which is implementing this methodology on a operational manner for different estimating yield of different state for the wheat, rice, cotton, many other crops also. So it is working very well at the state level as well as district level. But we have tried for the sugarcane also this methodology to best estimate with the all different satellite, with the either microwave satellite, INSAT based solar radiation, Sentinel-2, to get the implement this same methodology of light use efficiency to get better sugarcane yield estimation, particularly field level. Earlier what we have seen that, okay, you can do at the district level or partial yield, but here you can even do with the high resolution field level estimation also. We have found very accurate. You can see here. Nowadays everybody is talking about artificial intelligence, AI and AI data center and so on. How AI is going to change the dimension or our life. So one of the technique is a machine learning, which is a part of this artificial intelligence, because there we are training based on our existing information. We are training the new models which are basically applicable to the all non-linear system. So like biological phenomena like agriculture, crop yield, all those are non-linear system. It is not simply like response of photosynthesis to temperature is also non-linear. Any process which is taking place within the plant system, that is a non-linear. So there, if we apply certain kind of model which are addressing this complex and non-linear nature of the process, then it can better address the quantification of crop yield. So here machine learning technique, that is a one technique that can be used along with the historical NDVI data, historical land surface temperature, gross primary productivity, evapotranspiration, potential evapotranspiration, and some meteorological data like precipitation, standardized precipitation index, growing degree days, temperature. We have collected for more than 20 years of data, all district level in whole UP. Then we have used along with the historical yield from the agriculture statistic at a glance from a Ministry of Agriculture and Farmer Welfare. Then we develop certain machine learning based model to forecast sugarcane yield of whole Uttar Pradesh. You see, western Uttar Pradesh, their high yield region is very high yield, mainly Saharanpur and this Haridwar, and these are very high yielding sugarcane belt. But you can see here Bundelkhand and this is a very low yield of sugarcane yield production. Then nowadays new approaches are coming up where okay we can integrate remote sensing data with the crop simulation model. Crop simulation models are nothing but they are mathematical representation of the principle and process of growth and development within the plant system. So they are nothing but inbuilt software program that simulate behavior of plant as a function of soil management and environment condition. That is called crop simulation model. Now these crop simulation model are mainly practiced for the optimum environment. But if we want to apply it on a regional scale for actual farmer condition, then we need to extrapolate or integrate it with the remote sensing. So we have best integration of remote sensing we can do with applying, integrating with the leaf area index, integrating with the evapotranspiration estimation, integrating with the soil moisture estimation, which can be possible to derive from the satellite data. Here you can see this crop model we can run with the remote sensing GIS, climate model which can use this crop model and climate model. Climate model mainly like okay WRF, RCM, those are model which can be useful mainly for generating weather, advanced weather like seasonal weather forecast, long range weather forecast, that can be used as a driving weather variable to drive crop simulation model like DSAT or JPIC or WAPOST. So because these all crop simulation model require main input driving variable is a weather, and getting weather for the lead time with next 30 days, next 40 days, weather prediction models are only the source. That is why we can use also improve weather forecast model with the satellite, and then you drive this crop simulation model along with the assimilation of remote sensing data, so we can improve the early crop forecasting. Here, so one example is remote sensing climate model mainly for weather data. NBSS LUP, National Bureau of Soil Survey and Land Use Planning, they have prepared whole India level soil map. So that soil data all you can use, integrate and run crop simulation model to get the regional yield. So this is one example that okay where ORISA 1 is calibrated, or you can say forced with the as remote sensing derived LAI to finally get the yield map. We have done also for Punjab, Haryana. You see lead time prediction 45 days advance, 30 days advance, 50 days advance, and this 7 days advance. So 45 days advance we are getting better accurately, more than okay 90% agreement with the observed yield at the district level. Here it means that with 40 days advance we could able to predict yield of at district level or at the 10 kilometer resolution very accurately compared to even 30 days advance, because it is more important to have representative weather condition over a space rather than only a one point measurement. Because in a one district you will get only hardly a one observatory, but if you use weather forecast, seasonal weather forecast with the 5 to 10 kilometer resolution, it can capture better weather variability over a space. So it can give better accuracy for the partial yield estimation of a particular region. So Mahanaburi National Crop Forecasting Center, which is providing operational estimate of crop production forecast for more than so many crops, least 3 range reset and satellite data are used. So this is a one puzzle, forecasting agriculture output using space, agrometeorology and land observation. So it is forecasted by before four kind of forecast is given by integrating all model what we have discussed: agrometeorology information, remote sensing information, and econometric. Different kind of model is used. Crop condition also we can assess with the remote sensing. Mainly one example is a, here you can see high very good crop, you will find very good high reflectance here, very high absorption in case of visible land, and particularly here in case of water absorption band, more healthy crop, more absorption of sphere wavelength compared to the stress vegetation. So different kind of reflectors in the visible, near infrared and sphere band gives you information about water content in leaves and also crop condition. So crop condition which is affected either by insect pest, water stress, disaster, drought and hailstorm. Different stress we can assess with the remote sensing. So you can see India have national agriculture drought assessment and monitoring system. So we are able to do this national agriculture drought assessment monitoring with the different kind of data like NDVI, SASI, soil moisture and other things. And now it is become operational. So mainly data use are NOAA, Terra Modis, advanced sweeps, which are primarily being used as of now for monitoring agriculture drought. So what is NDVI? Mainly it is NIR minus R. When stress condition, NDVI is always less than 0.2. When crop is healthy, NDVI is always more than 0.72. So it is NIR minus R divided by NIR plus R. So this concept, you can acquire data every weekly for agriculture drought monitoring. So one of them indicator is a VCI, vegetation condition index. Another is a temperature condition index. By combining both, we can compute vegetation health. So here you see VCI means your historical data. You can use 20 years of data and to compute vegetation condition index. So NDVI mean and maximum you can compute for particular week based on the historical data of 20 years. What is NDVI mean, what is NDVI max for that particular week, then put in the particular year NDVI of particular week, you will get VCI. Similarly, brightness temperature from the thermal data, or from the thermal data you can get brightness temperature. That brightness temperature you can rescale between maximum and minimum, and then finally you can get TCI, that is called temperature condition index. Why it is important? Because crop vegetation growth is highly sensitive to the soil moisture, which you can capture with the vegetation condition index. But TCI, temperature, reproductive growth is highly sensitive to the temperature. So you cannot capture that response of crop to the temperature condition, because whenever drought is there, temperature goes up. So that information during the reproductive growth, or information of sensitivity to temperature, you can capture with the TCI. When you combine both, it can give you a vegetation health product. Here you can see we have computed VCI for the eastern Rajasthan, and it is agreed well. You see 2002 all week under drought, red or yellow stress condition, but next year all weeks were green, that means no stress condition, and it is agreed with the crop moisture index in every week. Here you see less than minus means minus less than 0, from -1 to -3, that means condition is negative, moisture condition is negative. Here everything is above 0, means crop moisture condition is positive when normal year is there. So as I said, vegetation health, 2002, whole India, majority of part was under drought, stress. But before that, 2001, it was not stress condition. Another week also, 2002 was stress, another it is not stress. So scientifically, all these crop zone area, soil moisture, weather data, crop condition, all integrated to derive drought maps like this. You can derive every district level drought bulletin, which are the different kind of district has experienced mild drought, moderate drought, and severe drought. And advanced data you can use for the block level drought assessment. Nowadays, okay, government has given new guideline, but now people have also developed new combined index, like okay, we have done combined drought index by vegetation, combining vegetation condition, temperature, precipitation to get the combined drought index, which is better indicator for the drought. So these are the Bundelkhand region where we can better capture the drought condition of normal and abnormal year. New manual suggests that we should use meteorological based data, remote sensing data, soil moisture information, hydrological data, crop zone area. So based on meteorology, you can define whether drought is there or not. Then after, you can use either of four: soil moisture, remote sensing, or hydrology, or crop zone area. Either three category of this, if falls as a drought, then you can categorize it a severe drought. If it is two of this area is drought, then category is falling under drought, then it is a moderate drought. Then this kind of drought condition also need to be verified with the ground truth data, either UAV or some ground truth observation, to make severe to moderate. You can downgrade severe drought to moderate category for compensation based on the ground truthing. So that is a new guideline which okay, government has asked every state to implement for agriculture drought monitoring. Similarly, more crop for drop, Pradhan Mantri Bima Yojana, Sinchai Yojana, where more crop we need to improve water use efficiency, we need to adopt new irrigation practice, optimize irrigation practice. So to analyze this, we can also use satellite data, wheat yield, water use, and finally we can get water productivity. So this can be useful for identifying those hotspot area where we can improve water use efficiency. Also, it can helps to get better identifying water saving practice like micro irrigation system, where we can deploy micro irrigation system like drip irrigation, sprinkler irrigation, and so on. Horticulture development also nowadays, as I said in the first slide, identifying closed storage facility, identifying food processing park, so suitability analysis of the horticulture development, mainly in hill areas like where we are placed, Dehradun, Uttarakhand, Himachal, which is mainly hilly terrain, where okay, alluvial plain is not that, so cultivation of crops is largely limited, but horticulture crop thrive well. So horticulture crop, it is better terrain, better area to expand horticulture development based on the soil, terrain, and climatic suitability. So those kind of agroclimatic suitability can be analyzed with the geospatial data. Horticulture development also, mango orchard mapping also we can do with the where okay, mango is mapping with the different kind of techniques you can plant and you can map where mango is cultivated. Another is the agroforestry system. Now everybody is talking about carbon footprint, conservative agriculture, regenerative agriculture, how we can better mitigate climate change. So this is agroforestry system is one of the system that has got potential to support not only livelihood but also mitigating climate change, because agroforestry system that can sequester highest amount of carbon from the atmosphere. So we can identify those okay agroforestry where okay haze is there, surrounding okay crop, one haze crop, eucalyptus or poplar is there, where okay mango orchard along with the wheat crop, agro horticulture is there. So different kind of this agroforest system can also be identified, and we can study its potential for the carbon sequestration to support mitigating climate change. Crop insurance, there is one industry that apart from textile and other cold storage and food processing industry, there is one other industry is a crop insurance, because India farmers are always okay at the stake, and they are always facing a one or another kind of natural calamity, either flood, drought, hailstorm, or some outburst of insect pest. So they are supposed to prepare for the crop insurance, that is Pradhan Mantri Fasal Bima Yojana. Under that, they are paying some premium and they are secured for the crop insurance. So crop insurance index we can derive from the remote sensing data. Also crop insurance claim, to find out the what is the exact accurate crop insurance claim and crop loss is there due to hailstorm, pest and disease, or due to some flood damage. We can assess accurately with the satellite data on unmanned aerial vehicle based drone based images and crop cutting estimate. So that kind of technology now become more versatile, and it is being implemented by the government of India in the Ministry of Agriculture and Farmer Welfare. Hailstorm damage assessment, you see the application, one example before hailstorm and after hailstorm. So here you see that red pink patch means in FCC, that means very healthy crop. This is a healthy crop. But same after hailstorm, you see white ball hailstorm. So that all crop is damaged. Potato crop is completely damaged. So we could able to identify this both studied, okay, and how much vigor is damaged. Then every field, these are the boundaries of field, and different field level, how much damage is there. So some area you can see this moderately severely affected area is very high, mainly pink area. Severely affected area is very high in case of hailstorm damage in the Narhara village in the Meerut district. Hyperspectral also has got immense role, because we have talked many kind of remote sensing. Hyperspectral is a one remote sensing where acquisition of image for a particular target in a continuous spectrum. Here, because in case of multispectral remote sensing, only few bands, few discrete and widely spaced band, widely spaced multispectral band, we are observing information about the crop, 4 or 8 bands. But here, continuous narrow wave band spectrum we are measuring for the particular crop. So we can able to do things which cannot be done with the multispectral remote sensing because of that averaging signal, average signal. So here with the this particular multispectral remote sensing, which is discrete spectral band, it is highly sensitive, useful for crop type mapping, crop anomaly and soil. But hyperspectral, which is more sensitive to the physiology and biochemistry, so it is very much good stress indicator of water, yield and vitality indicator, means mainly stress, pest, disease, nutrients, salinity and water. Now I can tell you, with multispectral remote sensing, you can only identify whether your crop is under stress or not. So here what I want to say, like, okay, if you are ill, first you will go to physician. Physician will see only your hand and see you are having fever, and he will give you some medicine like Calpol or some paracetamol, because there is fever is a signal. So you will visit. So it is a multispectral. He will give some Calpol, something like that. Fever is a only signal, but what is happening inside your body internally? What are the problems? That can be diagnosed by the specialist, master doctor of medicine. So those specialists can only identify what is the actual cause of rise in fever, rise in temperature of our body, whether there is some pneumonia, whether it is some other kind of disease. So that kind of specialist is a hyperspectral remote sensing. Hyperspectral give you a what is the biochemical changes is taking place inside the plant system, what are the physiological changes taking place inside the plant system, that can be diagnosed and differentiated with the hyperspectral. So this is a one is a physician and another is a hyperspectral is a like specialist doctor. Okay. So here you can see rice brown plant hopper. There is a one pest. it is affecting in the rice. So with the hyperspectral data, you see 10 nanometer wavelength data, here you can identify, okay, without damage and with damage, brown hopper damage, there is a significant difference is there, all different kind of plant. So you can use this hyperspectral data to classify different kind of variety, to identify pest disease stress, to identify salinity stress, to identify water stress through radius band and so on. You see mango malformation. Also with the hyperspectral data, we could able to identify the different, okay, mango malformation also. Then last, UAV, unmanned aerial vehicle. Now we all are talking about UAV is not only useful for the defense or only for like taking good photos. It helps to identify crop condition, identify different kind of stress, and helps farmer to apply certain kind of management. So here you can say it is platform is fixed wing or rotary kind of wing. Flying height is around 50 to 200 meter. You can get image resolution to the point sub-meter, it's sub-centimeter also, 0.2 centimeter kind of resolution also you will get, few to point centimeter, few sub-meter. And here you can get UAV mounted with the different kind of sensor like LIDAR, SAR data, microwave sensor, LIDAR, thermal and optical. You can mount and you can acquire image in optical domain, SAR domain as well as LIDAR. So you can get height information also. You can get, okay, chlorophyll content. You can get leaf area index. You can get yield information. So here you see cotton crop yield. You can get evapotranspiration and crop coefficient image. So this is but only very high resolution within field variability. What UAV can give? Very accurate and within field variability of the crop and soil moisture condition, evapotranspiration estimation within field. So those information are very much useful for crop health monitoring, crop yield estimation and crop management, including fertilizer application, irrigation application and pest and disease crop management. Thank you. Thank you all. So अभी नहीं आते, बाद में तो अभी आएगा।
अब तो टी लेके आ रहे हैं।
तो फिर क्वेश्चन कितने बजे आते हैं?